This is a video summary of a paper, Mechanical Search, Multi-Step Retrieval of a Target Object Occluded by Clutter. When operating in unstructured environments such as warehouses, homes, and retail centers, there is often need for what we call mechanical search, finding and retrieving specific objects from cluttered bins, shelves, or tables. The primary contributions of this work are the formalization of this family of problems for robotics, the definition of a framework with which they can be tackled, and the implementation and evaluation of this framework for the context of mechanical search within an industrial bin. The general formulation of mechanical search is as follows. It involves a robot manipulating generally unknown objects in an environment such as an industrial bin in order to retrieve a specific known object. It does this by sensing the environment through a sensor such as an overhead camera and deciding on actions such as parallel jaw grasping, pushing, or suction grasping until the target object is retrieved. We propose an algorithmic framework for such problems made up of multiple state-of-the-art components from computer vision and robotics. The first stage of the framework involves processing of the sensed data via object segmentation and recognition. This is done by taking sensed visual data, such as RGBD images, and using a segmentation model to produce a mask for each object. The masks are then used along with a set of images of a target object as inputs to a one-shot object recognition model, which produces a probability for each mask on wherever it contains the target object. The masks and associated probabilities are then used as input to the search policy stage. A high-level planner selects a single mask as input to a set of action policies. The policies output a set of actions and associated quality metrics, and the high-level planner either selects among these actions or selects a new query object. Once an action is selected, it is executed in the environment. We implemented this framework in the context of search in a bin using depth-based Musgrave CNN for segmentation, a Siamese network for recognition, multiple prior works for action policies, and several different action selectors for evaluation. These include the random action selector, the preempted random action selector, the largest first action selector, and the human selector. For 250 physical trials, we observed that intelligently choosing objects to grasp and push can decrease the number of actions needed to retrieve the target. This is confirmed by many more simulated trials. We also observe that the number of actions needed scales linearly with the number of objects.